What I want to demonstrate here is how to use PolymathPlus to solve ordinary differential equations. In this case, we have 2 differential equations, but the procedure is the same if we had, say, 10 differential equations. The independent variable is t, and there are 2 dependent variables, ca and cb. And this is an initial value problem, so that means that when t is 0, we're given values for ca and cb. These 2 constants, k1 and k2, values are given here. And we're going to integrate from t equals 0 to t equals 8 in this example. So let's open Polymath and then look at how we enter these equations into PolymathPlus. So the first thing I want to do is I'm going into Edit and Font and make the font bigger so it's easier to see in this screencast. And so the way we enter the differential equation, and let me make that visible also. So to enter the first equation, the procedure is to write it with the variables inside parentheses. So this tells Polymath what the variables are. And so first equation, k1, there's no subscripts. Multiplication is star. So that's the first differential equation. And by entering this format, Polymath knows it's a differential equation. And then we enter the initial conditions, and that's at t equals 0, ca is equal to 10. So let me pause and I'm going to enter the second differential equation because it's the same procedure. Well, the only difference to note is that in Polymath, to make a cb raised squared, we use the caret symbol. So we've put in again the initial conditions for component B, then we just type in the values for the 2 k values. So in Polymath, it doesn't matter which order I put these equations in. It knows. So I could put the constants first, I could have put this equation and then put the initial values. That doesn't matter. If I want to put a comment, use the number sign, and I can call this a mass balance. And a comment, of course, could also be on a separate line. Now I should save this, so I can go into File and Save As and then type in a file name. Well, the only thing left is to give it the starting conditions for t, which is, in this case, 0. And the final conditions, so we use F in parentheses to indicate the final conditions, which is a value of 8. Well, we're going to want now to solve this, so let me display the full part so we can see the solution. So hit this to solve, and what it gives me is a table with the various parameters, their initial, final values, and their minimum, maximum. And it gives a graph, so CA decreases with time, CB goes through a maximum. It also shows the equations, and because of conditions I selected, I'll show you in a few seconds, it gives a table of data 50 values, the same values that are used to generate the graphs CA and CB as a function of t. I've gone to settings and I've set the number of digits as 5. The default is 10, and that's just too many to display. And then I set this verbose to yes. If it's set to no, I won't get that table with all of the values. And when I make a change, for example, if I were to change this to no, then I'd want to select Save Changes here for that to then appear from all the other Polymath programs. So the report solves the differential equations very quickly, easily. The formatting is almost the way you would just write down the differential equations. The important point is that the dependent variables and independent variables in the left side of differential equation are in parentheses.